Okay, good morning, Year 12 further mathematicians. Just going to move on to 11.6 integration by parts. It's another method for integration you need to know. I'm going to try and apply this integration method to a variety of questions. So it all stems from this rule though, which is the product rule from the differentiation chapter. The product rule reads differentiate with respect to x, some product u times v, and it's equal to u dv by dx plus v du by dx. And the way this integration by parts formula comes about is it focuses on this term and makes this term the subject. So if I made that term the subject, u dv by dx, I would have to subtract this. Okay, now obviously this is differentiation, it doesn't contain any integration at all, but if you integrate every single term with respect to x, like so, one of these terms does simplify quite a bit. This first one stays as it is, there's no way to simplify that. But then this term is differentiating something, then integrating it, and they effectively cancel out with each other, so you're just left with the product uv, and then this term doesn't simplify at all. The reason why this term did simplify is because everything inside that bracket is differentiated, and then everything is integrated, so they cancel out. Whereas these don't simplify because only one thing is differentiated. And you're left with this. And this is a formula called integration by parts. And it's effectively the reverse product rule. Okay, so in other words, reverse product rule. Because you're going to end up starting with two functions. One of them is going to be called u, the other one is called dv by dx. And you're going to substitute it into this formula, and it should give you an integration which is easier to do. Because if you look at this left hand side, you've got an integration. Look at this right hand side, you've got one integration. The one on the left will be really difficult, and on the right will be a lot easier. So the aim is to use this formula to make the integral even easier to work out. And here's the first example. We've got to find out what x cos x integrates to with respect to x. And again, using the term reverse product rule, we've got a product, x times cos x, and then we've got this formula. So comparing this to this formula, if you just go by the order, then the letter u would actually match up with this letter x. So u is equal to x. And then the second thing is equal to dv by dx. So dv by dx is equal to cos x. Now it's not guaranteed that the order there will be perfect. Sometimes u is the second thing, sometimes dv by dx is the first thing, but this does work. Okay, now if you look at the formula on the right hand side and what it contains, it's got a u and a v. We've just got a u, no v. And it's got a v and du by dx. And we have neither of those. However, you can work them out. So if you've got u, you can work out du by dx, which is 1. And if you've got dv by dx, you can work out v by integrating. And cos x integrates to sin x. You don't need the plus c in integration by parts yet. Okay, but we don't need that yet. Now, this is everything now in that formula. So if I call that I is equal to the formula says uv, u times v, x sine x, subtract, integrate v times du by dx, v times du by dx, so sine x times 1, which is sine x, dx with respect to x. And if you look at that first integral, we had to do this, x cos x with respect to x, and look to see what we've got. The integral we've got now is a lot easier. We've got the x sine x at the start, and we only have to integrate sine x, which we should know. So this is easier. So we've got x sine x, subtract. What does sine x integrate to? That would be minus cos x plus c, or x sine x plus cos x plus c. So integration by parts is the reverse of the product rule, and you start off with an integration you can't do, and you end up with an integration you can do, and then you just integrate, and remember the plus c is normal. So reverse of the product rule. See what an EG number 2 would look like. Okay, so we've got x squared ln x with respect to x. And reminder that integration by parts is integrate u dv by dx with respect to x. And it goes to uv subtract the integral of v du by dx with respect to x. And good news is this is given in the formula booklet, by the way. Now, let's see. So I'm going to do something wrong with this one. So if I just follow the pattern of u is x squared dv by dx is ln x, let's see what happens. So u is equal to x squared dv by dx is equal to ln x. And I attempt to find out what du by dx is. I find out what v is. I can differentiate x squared, which is 2x, but I don't know how to integrate ln x. At the moment, you guys should know what this is, so it's an incomplete thing in the formula. So we must have got the order wrong at the start. So we go to swapping them around. So u will be ln x, because we do know to differentiate ln x, which is 1 over x, and dv by dx will be x squared, and we do know to integrate x squared, a third x cubed. And let's see what happens when we use the formula on this. So I'll call that I again. So I is equal to uv, u times v, so you've got ln x times a third x cubed, subtract, integrate v du by dx, so a third x cubed times 1 over x with respect to x. Now let's simplify things just to see if this is easier. So I'd write that as a third x cubed ln x, subtract. Okay, what does this simplify to? Well, that divides that to give you integrate a third x squared dx. And now if we compare what we started off with, which was x squared ln x with respect to x, to what we have to integrate now, this is a lot easier. And we can do this, which is a third x cubed ln x, add 1 to the power, divide by the new power, so you get a 9th x cubed plus c. Again, just write the plus c in right at the end. Right, this one is a little bit harder. So we've got x squared e to the x with respect to x. Now with this reverse product rule, you'll see the pattern of one of these you have to differentiate and one of them you have to integrate. Now 9 times out of 10, if you've got like a quadratic or a cubic or something like that, or an x, that's the thing you want to differentiate, because you want the power to go down, makes the integration easier long term. So for this one, I would choose u to be x squared and dv by dx to be e to the x, because e to the x I can integrate or differentiate, it doesn't really matter. It goes to the same thing. So du by dx would get simpler, it goes to 2x, and this integrates to e to the x. So if I call that I would be equal to, formula says uv, so u times v, x squared e to the x, subtract, integrate v times du by dx, so 2x e to the x with respect to x. Now that is a little bit easier than the initial thing. We've lowered the power from an x squared to an x. Still got an e to the x in it though, and unfortunately this thing I can't integrate. So what you actually end up doing is integration by parts twice. We have to use it again. Now got to kind of keep the order the same. If you don't keep the order the same, you'll go around in circles, but I'm going to call that u and that dv by dx. So u is equal to 2x, dv by dx is equal to e to the x. Let's differentiate to find du by dx, which is 2. Let's integrate e to the x, that's the easy bit. So that thing there would be I is equal to x squared e to the x subtract, and we're going to use the reverse product rule, or this integration by parts, wherever you want to call it, inside that square bracket. So integration by parts said uv, so 2x e to the x, subtract, integrate v du by dx, so that times that, 2 e to the x with respect to x, like so. And finally now, we started off with an integration we couldn't do directly, and we've ended up with an integration we can do. You should know the answer to this. If you expand and simplify, it goes to x squared e to the x, subtract 2x e to the x. Subtracting a negative is plus, and what does 2e to the x integrate to? 2e to the x plus c, and that would be your final answer for this one. So yeah, sometimes you have to use integration by parts twice. So yeah, that wasn't the easiest one. Last question. E.g. number 4. If you remember a couple of examples ago, I said you couldn't, or you didn't know how to integrate ln x. And now in this example, we're going to try and do it. Okay, this is again the integration by parts subsection. And integration by parts, I've told you, is the reverse product rule. And the problem is with this one, there only seems to be one function. So how can you use the reverse product rule if there's only one function? And the key thing is, there's a trick to do this. You write it as 1 times ln x. 1 times ln x. So the function is 1, effectively, and the other function is ln x. And now, if you pick this in the correct order, u needs to be the thing you can differentiate, dv by dx needs to be the thing you can integrate. At the moment, you can only differentiate ln x. So that has to go there, and 1 would go there. Du by dx you know what ln x differentiates to, 1 over x. You should know what 1 integrates to, which is x. Now normally you don't want to make something more complicated by integrating to get higher powers of x, but you'll see that this trick works for this one. So call that I is equal to integration by part says uv, so x ln x, subtract the integral of v times du by dx, so x times 1 over x dx. And again, this is all to do with the limits 1 and 2. So we've got to put the limits in as well for this one, 1 and 2, which is equal to x ln x subtract. They cancel out, and you are just integrating 1 with respect to x. Put that in there. You can include the plus c, but you don't need it. And this is between 1 and 2. And then if you substitute in the upper limit, you get 2 ln 2 subtract 2 subtract 1 ln 1 subtract 1. Okay, what does that simplify to? Well, 2 ln 2 is 2 ln 2. Yeah, just substitute the upper and lower limits in, but 2 ln 2 is 2 ln 2, subtract 2. Now ln 1 is 0, so that disappears, and you are just subtracting negative 1, so add in 1, which is 2 ln 2 minus 1. Let's just check to see if that is correct. You can always check the definite integration on your calculator, so ln x between 1 and 2 gives you, calculator's going to think for a bit, 0.386, and 2 ln 2 subtract 1 is exactly the same. So yeah, that's correct. Now the questions I would like you to try, just find the page. Okay, so it's exercise 11F. And if you do questions 1, 2, 3, 4, but just do parts, let me think about this, parts A and D only, from those. And then next page, if you try question 5 and question 7, and that'll be it. So exercise 11F, which is on page 309 and 310. Any questions about this, just post a message in the Teams chat.